power of powers, like a to the power of m raised to the power of n, or, yes, you got it correct, negative exponents. 1 by a to the power of m is equal to a to the power of minus m. So we will clarify all this. I know you have a problem there. If it is there, ensured today it will be taken care of. And those who do not have problem with these, please have a great revision, and I'm sure things will work out the way it should. So let's see what we have in store for us. Now see, a to the power of m whole thing raised to the power of n. What does it mean? So when you do it, it happens like this: a to the power of m times n. For example, 3 raised to the power of 3, and this is raised to the power of 4. So what will happen? 3 times 4 is equal to 3 power 12. Simple, right? Now see, before going further into this, I would like to introduce the concept of negative exponent. What is it? I know it's a dicey issue, difficult, confusing. Let's see. See, a to the power of m, we can write it as by 1, right? Now see, this is called the numerator. We'll call it n, and this is called the denominator. We'll call this d, right? Now see, when this numerator comes to the denominator, like 1 by a to the power of m, what happens? See, this is positive. This becomes negative. See, this is the change, right? So this means, in a nutshell, a to the power of m is equal to 1 by a to the power of minus m. Have you understood? It has gone from the numerator to the denominator, and the positive sign has changed to negative sign, right? Similarly, if we write a to the power of minus m, this will become a to the power of m, because the numerator has gone to the denominator and the power has become positive, right? Is it understood? Let's have an example. 2 to the power of 2, see, it is like this. Now when you bring it to the denominator, it becomes 2 to the power of minus 2. See, this sign has changed, correct? And the 1 comes up top. Understood? So, again we interchange both numerator and denominator, like a by b to the power of n, right? Now if we write it this way, this becomes negative. Have you understood? See, the b has gone to the numerator and the a has come to the denominator, and they have changed their power to negative sign, like a to the power of n, b to the power of n. When b goes up, it becomes b to the power of minus n, and a comes down, it becomes a to the power of minus n, right? So since the powers are same, we can write b by a to the power of minus n. Is it understood? Let us have a numerical example. Suppose we have 2 to the power of 2 raised to the power of 2 divided by 2 to the power of 3 raised to the power of 2. Correct? First, we applied this rule. A to the power of m raised to the power of n is equal to a m into n. So if you do that, the numerator becomes 2 to the power of 4 and the denominator becomes 3 to the 2. The denominator becomes 2 to the power of 6. Right? Now we can apply this rule. A to the power of m divided by a to the power of n is equal to a to the power of m minus n, that we learned in the last class. By the way, you are with Have Fun and Learn, and I am GP Datta. It appears that you people are so engrossed with the classes that you forgot to hit on the subscribe button. Would you please do it? It will inspire me. Okay, coming back to the topic. Now see, if we apply this here, you get 2 to the power of 4 minus 6, which boils down to 2 to the power of minus 2, right? What is the meaning of it? This is divided by 1. You can always write that. So this comes in the denominator. So 1 by 2 to the power of 2, which is 1 by 4. Right? Is it understood? Correct. Pause and think, and any questions you've got, you can put in the comment box later on. I'll handle it. Before going further, I want to ask you 2 questions. Can you tell me how do you represent root over 3 in terms of exponent right? Number 2, this is question number 1. Question number 2, what is the difference between two root 2, 3, and can you? I'll solve, don't worry. Put all your concentration now here. See, this can be represented in terms of exponent as 3 to the power of 1 by 2, a fraction, right? The difference between these two is 2 multiplied by root 2. This difference is 3 multiplied by root 3, and this means 3 to the power of 1 by 3. Correct? Now one more question. Can you simplify it to the exponents, all this? This will imply 2 to the power of 1 multiplied by 2 to the power of 1 by 2. Correct? Right? So if you add it up, 2 to the power of 1 plus 1 by 2. Correct? So this gives you 2 to the power of 3 by 2. Right? Correct. That can be written as square root of 2 cube. Now this, This means 3 power 1 by 3, right? Now if we go on to simplify this, let us simplify that part, right? So 3 multiplied by 3, third root of 3, this will give you 3 to the power of 1 multiplied by 3 power 1 by 3, correct? Understood? This is equal to 3, 1 plus 1 by 3, which is 3 power 4 by 3, right? So that will boil down to third root of 3 to the power of 4. Understood? This is what I was talking about. Now why all this? Suppose we have a problem like 5 by 8 to the power of 7 multiplied by 8 by 5 to the power of 11, correct? So see, here the base is 5 by 8 and here the base is 8 by 5. 8 by 5 is reciprocal of 5 by 8. So 8 by 5, have a look. 8 by 5 to the power of 11 can be converted to 5 by 8 to the power of minus 11. Do you remember I wrote down a value? A by B to the power of n is equal to B by A to the power of minus n. Right? So we write here 5 by 8 to the power of 7 multiplied by 5 by 8 to the power of minus 11. See, now the bases are same. Bases are same. So 5 by 8 to the power of 7 plus of minus 11, which gives you 5 by 8 to the power of 7 minus 11, that gives you 5 by 8 to the power of minus 4, and we can make it positive, the power positive, by writing 8 by 5 to the power of 4. Correct? Understood? Is it clear? Okay, now see the synopsis. The dynamics of what happens when the exponent becomes negative. See, numerator divided by denominator, right? Say a to the power of m and a to the power of n, correct? Now, when the numerator goes to the denominator, the sign of the exponent reverses, right? Like here, the numerator goes to the denominator, right? So it was a to the power of m. It becomes a to the power of minus m, correct? Similarly, when the denominator goes to the numerator, it reverses the sign, right? So here the denominator goes to the numerator, so this goes up, so a to the power of minus n. So we can write a to the power of minus n divided by a to the power of minus m is equal to a to the power of m divided by a to the power of n. This is the final synopsis. Correct? Now the list of rules becomes longer. 1, a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. That was we learned. Number 2 also we learned. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. We applied and learned. Today we learned a to the power of m raised to the power of n is equal to a to the power of m times n. Also I told you a to the power of 0 is equal to 1. Now number 5 is a to the power of m is equal to 1 by a to the power of minus m. And number 6, a by b to the power of n is equal to b by a to the power of minus n. Right? So the list of formula changes here. Now, that will be all for this class. In the next class, we pick up this particular rules and we solve problems associated with these two rules and find out where it leads to. Now I'm sure at this moment, whatever doubt you had about negative exponents should be gone. If not, please ensure that you see the next video where things will become clear, even more clear. Or rather, I would put it this way, things will become even more clear. Correct? Please don't forget to hit the subscribe button, share and comment. I need inspiration also. Okay? Till next class. Bye-bye. And keep watching educational videos which are helpful. Thank you.